So I'm just going to say again, these are your trig identities. If you're just watching this on a video because you missed my class, then take pictures, right? And we're going to use all of these identities to do some problem solving. Now, the parts that you guys are working on are where you're going to start by applying your trig identities. So we're going to move up here and we're going to make our screen full size again. We're going to go applying trig identities. And that's what we're going to be doing today for the most part. We're going to apply them and then we're going to prove them. So if we let theta be an acute angle, right? And that means, what's an acute angle? It's less than 90 degrees, right? So we're going to say that such that sine of theta equals 0.6, right? And we're going to find the value of first cosine of theta and then tangent of theta. That's A and that's a B. Using the trig identities, right? Not a calculator. We want to use trig identities. You're doing it on paper, so you're going to show me how you did it. So the way I look at it is, okay, if I've got A, I'm looking for part A, I want cosine of theta. I'm going to look for an identity that has cosine and sine, right? And the first one I'm going to see this Pythagorean one, right? It's got only cosine and sine. I know what sine is, right? I know that it equals 0.6. So I'm going to use this to find out. I'm going to use sine squared theta plus cosine squared theta equals 1. And I'm going to use it to find what cosine squared of theta is. Now, the first thing I know by this is that sine of theta is 0.06. So I could just write that, 0.6 squared. And I know that plus cosine squared of theta equals 1. So now I can just do the math. Well, I can subtract 0.6 squared from both sides, right? And I would get cosine squared of theta equals 1 minus whatever 0.6 squared equals. Now I have to actually do the math on that. And that's going to give me that cosine squared of theta equals 1 minus 0.36. So I could also say that cosine squared of theta equals 0.64, right? 1 minus 0.36 is 0.64. And then just like anything else, we can take the square root of both sides because this is cosine squared of theta. And if I take the square root of both sides, I get cosine of theta equals 0.8. Does that make some sense to you? I'm going to show you more. You don't have to rest on just that one. So that would be how we found our cosine of theta, right? But we also have to find tangent, right? We need to know what tangent of theta is. But what do we know about tangent of theta? Or what I know about tangent of theta is that it is just equal to sine over cosine. I'm looking for tangent. I have sine and cosine, right? That's how I know which ones of these to look at. What am I looking for and what do I have? And which one of these identities will give it to me, right? I know I have sine because it's given to me, and I have cosine because I just figured it out, and I'm looking for tangent. So what has tangent and sine, or tangent and sine and cosine? And that's this one right here. So I am going to use the trig identity that tangent equals sine of theta over cosine of theta, right? And we know what those are. That's going to be 0.6 is sine over 0.8, which is cosine. And when I put that into a calculator, or even when I solve it out, you can tell that it's going to be 3/4, which is just 0.75. Does that make some sense? I know that this is new stuff for you guys. It's not something you've done before or anything like it, which is why I'm doing multiple problems and why I did some of your homework problems. But are you getting it a little bit? Like, does it make some sense to you? Did I lose all of you? I'm gonna take a sip of coffee. Like, Carla's getting it. William's getting it. Just know that if you start doing these and you have any questions, I'm gonna do more of them for you, Avery. We can always pop into Google Meets because I know it starts to get easier to understand stuff as you do it. It's harder to understand while you're just watching. So yeah. So let's do another example. Same thing. We're gonna let theta be an acute angle, blah blah blah, right? Be acute angle such that I'm only writing these out because that's how you're going to see them in the homework, and I want you to be able to recognize what it's asking you for, such that tangent of theta equals 1/3. So it's telling us what tangent is, right? And it wants us to find the value of A cotangent theta and B secant of theta. All right, so we're going to start with A. We want cotangent of theta, right? What do we know? We know that tangent equals 1/3. So this one's not so bad. If we go up here, we're looking for cotangent and we have tangent. So if I look at this, I don't see anything in here that's going to work for me. I have a cotangent, but it doesn't have tangent. I have a tangent, but it doesn't have cotangent. Here I have a cotangent, but it doesn't have tangent. And here I have a tangent, but it doesn't have cotangent. But here I can see that tangent equals 1 over cotangent, where cotangent equals 1 over tangent. I can use either of those to figure it out. I'm going to go with, we're asking for cotangent, so I'm going to go with cotangent. I know that it equals 1 over tangent, right? And I know that the tangent is just 1/3. So I'm going to write that as 1 over 1/3. And then I can solve that because I've got a fraction under what's technically a fraction. 1 over 1 would be the fraction. I can multiply that as 1 times the reciprocal, which is 3 over 1. And I just get that the cotangent of theta is 3. For part B, we are asking for secant of theta. What do I know? I know the tangent and I know the cotangent, right? So I am going to go back up and see what I can do with that. I'm looking for secant, and so I need something with secant and either tangent or cotangent. This is why I tell you it helps to have all of these written down so that you can just look at them when you're doing it, right? I have secant, right? And I have tangent and cotangent. I like this one, right? Because it's got tangent and secant, and I know I have 2 of those. I know I'm looking for the secant, and I have the tangent, right? This one doesn't work for me because it's got the cotangent, which we have, but we don't have the cosecant. We're not looking for either of those. So I'm going to use 1 plus tangent squared theta equals secant squared theta. I'm going to go back here. So what do I know? I know that 1 plus tangent squared theta equals secant squared of theta, right? And what we know about that is that tangent equals 1/3. So 1 plus 1/3 squared, right? Because tangent is 1/3. This is tangent squared, so it has to be 1/3 squared, equals secant squared of theta. And we can just do the math on this. This is like saying 1 plus 1/9, right? Because 1 squared is just 1, 3 squared is 9, equals secant squared of theta. Well, that's like saying 9/9 plus 1/9 equals secant squared theta, right? We have to find our common denominators. Whew. And so I'm going to get 10/9 equals secant squared of theta. And to solve that, I don't want to know what secant squared is. I need to know what secant is. So I'm going to just take the square root of both sides. And I'm going to get the square root of 10 over 3 equals secant of theta. So we could come up here and write the square root of 10 over 3. So we're doing equation solving, right? That isn't new to you, but doing it with trig is a bit new to you, right? We're going to do one more problem, right? Because the first part of your homework is going to be giving you a value like this, and you're going to have to find the parts. They have A, B, C, and D. I'm only asking that you do A, B on each one of them. The second part is going to ask you to use the identities to prove something, right? It's going to say, I'm writing with my eraser. Using trig identities, use trig identities to transform the left to the right. Mathematically speaking, that means that we're just proving something to be true or showing why it works. So if I have, let's go with A. sine of theta times the cosecant of theta equals 1, I need to prove that, right? Is what it's saying. What I know about sine of theta, oh man, that got super tiny. What I know about sine of theta is that it is 1 over the cosecant of theta. And we're dealing with sine and cosecant. So I'm going to scroll way back down. So I could really rewrite sine as 1 over cosecant of theta, right? Because if they're equal to that, that means I can swap them out, times cosecant of theta, right? And if we look at that, that's like over 1. Technically, anything can be written over 1, right? These would cancel each other out if we were multiplying, because if we did that, that would be the same as saying cosecant of theta over cosecant of theta, which just equals 1. So I used trig identities to transform the left to the right. What if we had cosecant of theta plus cotangent of theta times the quantity cosecant of theta minus cotangent of theta. Now, these are just binomials being multiplied to each other, just like any other binomials being multiplied to each other. So I could go ahead and just multiply those out. And I can go cosecant times cosecant. Well, that's going to give me cosecant squared of theta. And then I'm going to do the same thing to this part. That's going to give me minus cosecant theta times cotangent theta. And I'm going to do the bottom, right? Because I've multiplied this times everything already. That's going to give me plus cosecant theta times cotangent theta. And then we're going to multiply it times here, and I'm going to get minus cotangent squared theta. And if you look at this, this is a difference of squares. And this is the minus version of this, so they would just cancel each other out, right? Cosecant minus cosecant theta cotangent theta plus cosecant tangent cotangent theta is just 0. And so what we're left with is going to be cosecant. Oh, this is supposed to equal 1. Sorry. Cosecant squared of theta minus cotangent squared of theta. And we're saying that that would have to equal 1. And how would we find out if it does? Well, we have one of the Pythagorean identities, I believe, has cosecant and cotangent, right? We can slide up here and we can look at our identities, which is why I say you should have a piece of paper with them. This one right here, 1 plus cotangent squared theta equals cosecant squared theta, right? Slide all the way back down. So what do we know? We know we have a really tiny screen. This is like the longest lesson I think we've had all year. And it's not even a full lesson. Could you imagine trying to do this entire section in one class, all of 4.3? So we know that we have the Pythagorean identity 1 plus cotangent theta squared equals cosecant squared, right? So we can just subtract cotangent squared theta from both sides, right? And we get that 1 equals cosecant squared theta minus cotangent squared theta, which is exactly what we have over here, so that we can say that equals 1, right, by Pythagorean identity. I know that these are tough to wrap your head around if you've never done them before. Play with them. They're like a puzzle. But when you play with them, make sure you have all your identities in front of you, right? So that you know what to pick and choose from. The trick is to go, well, what do I have, right? What am I looking for? What do I have? And which one of those identities contains both of those things? Play with it a little bit. And if you struggle with it, we can always go back and look at it. Your homework is posted. It's page 285, numbers 38 through 52, evens only. That first part, that first section has A, B, C, D. You only have to do the A and B on them. You don't have to do the C and D. That's just too much. If you have any questions, let me know. Or when I see you guys on Thursday, bring them up. We can work on those in class. But if you don't have any questions as of yet, I understand, because sometimes I think you need to play with stuff like that to understand what you do and don't know. But do you have any questions regarding what we did here today? I got one no.